Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So in order to see the true nature of gravity, we have to remove the air. It takes 3 hours to pump out the 800,000 cubic feet of air from the chamber.
Okay, we dropped 2 millitorr in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCB 30-1, pressure set point at 240 psi. We are go for drop.
10, 9, 8, 7, 6, 5, 4.
I wonder why the photographs look so different to the others. They're in black and white and really faded.
That's an interesting question.
Wow! You're from the photograph. Who are you?
I'm an optical engineer. These photographs are unlike the others because they were captured using older cameras.
Really? Why are they different?
Well, let's go on a journey back to the 18th century. This is the camera obscura. It's where the word camera came from. It means dark chamber. Let's take a look inside.
It sure is very dark in here.
Well, that's because the camera is a light-proof box built to capture light.
Wow, what's that?
That is a daguerreotype camera, developed from the camera obscura. It captures images on a silver-coated copper plate. It was developed in 1839. However, this is the first photographic film camera, and it was invented by Kodak. It uses film strips containing light-sensitive silver halide crystals to capture images and was first introduced in 1888.
How does a camera work, though?
Well, a camera works the same way as your eyes, Alex. The diaphragm of the camera is like the iris of your eye and determines the amount of light entering the camera. Behind that, there are lenses. Light bends when it travels at different speed through different mediums, such as from air to glass. The light is then focused to a central point. When you click on the shutter button, the movable mirror flips upward in the camera. The light stops when it reaches the film in the camera or the retina in your eye. Each forms an inverted image.
Then why is the image upright when we see it in the camera?
It's because there's another light path. When the shutter button is released, the movable mirror returns to its initial position. A pentaprism in the camera rotates the inverted image upright in the viewfinder. Even more amazing is when the image reaches the retina in our eyes, our brains process it to appear upright.
Oh, so that's how the camera works. I have another question. What about digital cameras?
Good question. As camera technology evolved, the way images were stored changed too. Photographic film strips were replaced with electronic film, giving birth to the digital camera era. Instead of using chemicals to react with light to form permanent patterns, electronic film picks up colors on a light-reactive surface and converts them into electric signals. These electric signals can then be translated by a computer into an image that can be displayed on any type of screen, like a computer screen or a TV. This is different than the old film strips, which could only be printed on paper. These digital images can be stored, shared, or deleted from the memory card at any time. Want to know more about cameras?
Absolutely, yes!
Amazingly, cameras can detect all types of light, both visible and invisible. Light is actually a wave of energy called electromagnetic radiation. Cameras can be designed to detect these waves at all different sizes.
Really? Like what?
Like thermal cameras. Thermal cameras can detect longer electromagnetic waves, which are created by hot objects. Therefore, a thermal camera can capture and display the temperature of each object in its picture. However, X-ray cameras detect special electromagnetic waves that are very short and wiggle very fast, allowing us to see bone structures and also to see through walls. But these are only two examples. There are many, many more.
Wow! All that evolved from the first camera? That is so cool!
Oh, and Alex, happy snapping.